Today we're going to save, get the calculator ready Carlos, 66 euros for a crank, 120 euros for 3 instrument covers, 100 euros for a sextant, 5 euros for the hose adapter, what more, well, and 3,000 euros for an electric winchy. Let's see, how much does that add up to?
Well, let's see. 3,291 euros.
Well then, today we're saving 4,000. Save 3,291 euros on a lot of accessories for the boat, because today we are going to take our first steps in the world of printing in 3D, from learning how to handle the printer to design some simple parts ourselves. Do not miss it, because this 3D printing is a world of possibilities, super affordable and, above all, fun.
This episode doesn't just leave an impression. It prints it. It prints it in 3D.
And that's why I write the scripts. Greetings sailors, and welcome to a brand new episode of the Low Cost Sailor. In today's episode we're going to take our first steps into the world of 3D printing. We'll discover how affordable and easy it is today to use a 3D printer, how useful it can be both in our daily lives and in repairs and projects aboard our boats, and above all how incredibly versatile it can be to have the ability to manufacture a spare part in the middle of the ocean. We will see how printers work, the types of materials available, how to make our first prints, and the enormous amount of parts that already exist ready to print without needing to know anything about design or anything else. But we will also learn how to easily design our own custom parts with TinkerCAD, a free and very intuitive online tool. Don't miss it, because you are going to discover a world of possibilities with 3D printing that you might not known about.
And the girls have asked me to make them some Pokemon toys or something like that.
No, you can't do that.
I think you can...
No, I can't. Well, okay, I'll make them. 3D printing is a technology that has been with us for a long time. Although it may not seem like it, it emerged in the 80s, but it didn't start to become popular among home users and small businesses until the decade of 2010, around there. Companies like MakerBot or Ultimaker started making affordable printers and software for the end user. It was around that time that the first 3D printers came to my job. We used them to make prototypes of encasements and specific tools for the fabrication and installation of electronic devices. Perhaps having known about 3D printing so early, and having seen how engineers suffered with those first machines, the lack of adhesion of the parts, the constant failures, the jams in the extruders, left me, never better said, with the impression that I needed a master's degree to be able to use them. And to top it off, the prices of printers and materials were still quite high. Of course, even back then I asked my colleagues to print me some small things for the boat, like the covers for the instruments or some simple parts. But of course, it was completely up to them. But all that has changed. My colleagues were already telling me that modern printing was child's play. So a couple of years ago, with printers much more evolved, I decided to ask the Father Christmas for one. I must not have been very good that year, because he didn't bring it to me. But this Christmas my kindness, hard work with my children and effort were rewarded, and finally Father Christmas brought me my first 3D printer. And how have things changed? On my first attempt with the default settings and basically doing nothing, my first piece came out successfully. And that's when it all started. Especially when I started preparing this episode, I went crazy to print and discovered how easy it is today to use a 3D printer. And above all, how useful it can be. From making custom parts, aesthetic finishes for the boat, small utilities, to tools that would be very difficult to make by hand. Everything is possible. In just a couple of weeks, my boat is filling up with 3-dimensional printed accessories. Hand in the season.
I can't believe we hadn't done an episode on 3D printers until now.
Because honestly, I had no freaking idea what I could do with a 3D printer. And now I can live without them. My wife has already told me, you're going to take this to the garage or somewhere else, right? It makes a lot of noise and it's on all day, but it is what it is. A question I get asked a lot is, what inventions or tools would you take with you around the world? Well, this list is growing little by little. The Starlink, which I think is essential to be communicated in any corner of the ocean. The battery-powered scuba diving equipment to deal with emergency repairs. Our Raspberry Pi with the complete Wikipedia. All the knowledge of humanity. Most of all, if it all goes to shit, well, that's where I keep it. Available in our store, of course, available in our online store, and now, without a doubt, a 3D printer. The possibility that someone can send you a spare part over the internet, a 3D model, and print it yourself for an emergency repair, I think is simply unmatched. And we're going to see it in this episode. A cast iron. Over here I've got, look, one that I made myself, okay? A broken one, a reproduced one. A sealing gasket. A belt, a toothed belt that you can print, for example, to replace the one on the autopilot. These are things that today you can print with your own printer, and you don't have to know much because I don't know much either, and I've done it, so... There are several printing technologies, but they are all based on the same concept, additive manufacturing. The idea is very simple. Very thin flat layers are deposited one on top of the other as if they were the pages of a book, which as a whole gives it its thickness. We build it up layer by layer until in the end the sum of these planes becomes a three-dimensional form. That is the basis of almost all 3D printers. And basically in the domestic world there are two main types of technologies, filament and resin. In the beginning, the most affordable technology for home users was the filament technology. It basically consists of an extruder head, which is fed by a roll of plastic filament, spitting out a thin thread of molten material. If we give this head the ability to move on the plane, like the old drawing plotters, you can draw any shape with that plastic thread. Now, if we slightly raise the plane layer after layer, layer after layer, that two-dimensional drawing becomes a three-dimensional structure. It is a reliable and relatively simple technique. The resolution of these printers depends on the thickness of the thread and the precision of the head movements. And the mechanical strength of the parts is determined by the adhesion between layers and the properties of the material used. But to overcome the limited resolution of filament printers, resin printers have arrived. They are capable of creating much thinner layers with an impressive level of detail. Their operation is different, although the additive logic is still present. Basically, it uses a tray filled with photosensitive resin which solidifies on contact with a specific light, usually ultraviolet. A printing base is gradually immersed in the tray while a light source, either an LCD screen or a laser, projects the silhouette to be solidified layer by layer. The piece is formed on the surface of the flask, which gradually emerges from the bottom of the liquid resin. Once finished, it has to be cleaned and cured, hardened with ultraviolet light, and we have a piece with spectacular resolution and details. Of course, these printers are much dirtier, cumbersome, require cleaning with isopropyl alcohol, subsequent curing, proper ventilation. In addition, resin parts are usually very accurate, but also more rigid and fragile. For those of us who want to use it in a boat, they have a major problem. The printer must be perfectly leveled and in static position throughout the printing because the resin is a fluid, and with the movement of the boat, heels or vibrations, the print can be completely ruined. Which one to choose? For the last reasons, and because filament printers have improved tremendously, both in resolution and variety of materials, they are still the most popular and versatile choice for home and home office use.
So with the filament ones, even if the boat moves, it works?
You can't use it in the middle of a storm because of the vibrations, but it's okay heeled over, and it works heeled over. It's not going to have any big problem. And then it was time to choose a 3D printer with which to start our first steps. The variety is almost infinite, and that can overwhelm us a little. In AliExpress you have 3D printers from €75. Luckily it seems that it is already behind us the time when the cheap thing was to buy a printer kit to assemble it yourself. That was a lot of metal, motors, a head, and many hours of turning it around. Now most of them come fully assembled or almost fully assembled. There are very good printers, and for example the hottest trend now are the Bamboo Labs, which have everything, even with multiple filaments of different colors to print at the same time. Well, it's insane. I was looking for something simple and affordable, and that at least would allow me to print covers for the instruments. So for me the minimum were pieces of 20 by 20 by 20 centimeters. And so I let the three wise men know. They who come from the Orient, they know very well my taste for Oriental things.
Of course, I thought about that the other day. The three wise men are from the East. The three wise men shop in China.
Yes, they get the presents from China and then they bring them here. Of course, that's why I like them so much. They decided to bring me a printer with a very good balance between price, quality, and ease of use. They brought me the Anycubic Kobra 2 Neo, capable of printing pieces of 25 by 22 by 22 centimeters with a contained volume. It is not very big, weighs 7 and 3 kilos, and has a maximum consumption of 400 watts. This is important in a boat. The parts are printed slowly and the printers consume a lot, but with solar panels or with one of those power stations we have, or especially in an emergency, you can print what you need. It will allow us to print anything. Parts in the most popular materials: PLA, ABS, PETG, and TPU. I cannot be happier with these first months of use. Very easy to use from the beginning and with very good results in the prints. Well, and that it came almost completely assembled. The complete instructions to set it up are in the manual, but it is very easy. Screw the frame on the base with 4 screws. It comes with all the necessary tools. Install the print head, the screen, and the support for the rolls of filament. Connect each cable in place. Everything is very well labeled. Adjust the position of the pulleys and belts and is ready to go. We can start printing. All this is about printing something, a model, a piece, something that can be useful or that we need at a given time. The easiest way to find something useful to print or to cover a specific need is to search in one of the many pages that exist with thousands and thousands of models already designed and ready to print thanks to a huge and very active community of users who share it. And when I say that there is everything, I mean almost anything you can imagine, from objects for everyday life to super specific pieces for boats. For example, the classic instrument covers, which can also be easily customized to include the name of our boat, or very specific parts that you would never imagine that someone has already designed. Here are some of the great places to search for 3D models. Thingiverse.com, one of the best known references, Cults3D.com with many free and paid models, STL Finder, which acts as a search engine for models on multiple platforms, or Jeggy, another very popular search engine. And of course, a quick Google search with the name of what you are looking for, followed by the acronym STL or 3D model, can lead you to some real gems. The first thing I printed was an adapter to use the battery drill on the winches of the boat, and thus convert them to electric in a very simple and cheap way. And it worked, but you can make your first prints with almost anything. Same with the logo of the low-cost sailor, which surprisingly is one of the things I found on those platforms, and that some of you uploaded because I didn't upload it.
Really? I mean, somebody made the logo of the low-cost sailor?
And it's uploaded on Thingiverse.
It's amazing.
In order to be able to print, we will have to perform 2 previous steps. The truth is that the Kobra 2 is very easy to use. We turn it on with its switch, and the first thing we are going to do is to load the filament. For the first test, it is easiest to use PLA, and the printer even comes with a small amount of test filament. Loading the filament is simple. We place the spool, cut the tip of the filament to avoid any part that is bent or dirty, and always start with clean material. Be careful not to wind the filament. The spools usually have holes on the sides to hook the tip when we are not using it. Push the filament through the tube until you find a little resistance, press the tab down and continue pushing a little more until you notice that it enters completely, and then go to the menu, filament, extrude, and when the head is hot we will see that the material begins to come out. We leave it like this until we see that comes out continuously and cleanly and everything is ready to print. A good practice, especially at the beginning, is to free the print bed. The Kobra 2 does this on its own. Just use an option in the menu that says auto level and that's it. And now we can print our first model. We install the Ultimaker Cura application on our computer. We look for something small and easy to start with in the post of our web or in some page of the models. The classic to start with is the benchy boat. When you download the model, you will get a .stl file. By double-clicking, it opens directly in Cura, where we can visualize it. We can rotate it, place it in the orientation that best prints. Basically, we want as much surface area as possible to be in contact with the base, because the areas that are left in the air will require supports that will have to be removed later. We will configure Cura by adding the model of our printer. The Kobra 2 Neo is in the list. We select the type of material, we can start with generic PLA and set the print parameters. Some important settings in the print parameters are the print resolution. The higher the resolution, the longer it takes, but the better the finish. I almost always print in normal mode, which gives a good balance between detail and speed. The percentage of infill determines if the thick parts are totally solid or if they have an internal mesh that gives consistency with less material. You will see that many parts can be made with low fills between 10 and 20%, but others, such as the drill adapter, will require 100% fill for maximum strength. And then there are the supports. Supports are temporary structures that the printer generates to hold parts hanging in the air. You can't print directly on air. Well, small distances you can print without supports, but beyond a few millimeters, no. At the beginning, always leave the supports on, and with time you will learn when you can remove them, because that will surprise you.
These supports, the program paints them by itself? You make a model and it knows which supports to make?
Right, this is this piece. If you print it like this, it doesn't need supports to do it because it all goes on top of something else. And this is the same piece. If you print it lying down, all this stuff that is added here are supports. Supports that you then remove them. Finally, there's the adhesion layer. This is key so that the part doesn't peel off the base during printing. I leave it on most of the time, except on large pieces with a lot of base support on their own. Just like the supports, it is easily removed by hand or with pliers. To improve adhesion, you can still use Nelly lacquer, which was used in the beginning of time when the beds were cold, and now with the hot beds it is not so necessary. But if you see a piece that slips, you can spray it with Nelly lacquer.
You have hairspray at home, don't you?
I use loads, like you. Yeah, I use loads. I use so much hairspray. Well, when we have everything ready, we press slice. The program will calculate the estimated time and will give us the option to see a preview of each layer. We save the file on the SD card, place it in the printer, select the file with the little wheel, and that's it. All you have to do is wait. Sometimes it will be a few minutes, sometimes a few hours, but with the magic of film, in this video, we can see how the pieces grow in a few seconds. There are many types of filament for printers in the world, and choosing the right one depends a lot on the use we are going to give the piece. The most basic and easy to print is PLA. It is ideal for latching and for decorative pieces or pieces that are not going to suffer mechanical stress. But beware, it does not withstand heat or humidity, so it is not the best option for the boat. Well, inside the boat it may work well, but outside with the sun and rain the filaments will degrade and the piece will end up unraveling little by little. Now, which are the pieces of our sextant, this is made with PLA. A very popular option today is PETG, which is almost as easy to print as PLA, but much more resistant to sun, water, and typical products. It is a very balanced choice for onboard parts, and will be the one we start with to make the first parts for the exterior of our boats. This is made with PETG. Look at the smooth finish, how nice! If we need something flexible, like a gasket or a padded backing, we'll use TPU, which is the elastic rubber-like filament. This strap, this is made with TPU. These gaskets are made with TPU. There are many variants of flexible materials, some with names as flashy as XXXX, which is the one that I bought, but because I saw an ad and they sold it to me, and that I've used in some of the flexible parts that you'll see in this video. The elasticity of these parts is a combination of the properties of the material and the internal structure that we give it in the printing design. If we want maximum mechanical and thermal resistance, this is where materials such as ABS or even nylon come in. Of course, they require closed printers, higher temperatures, and sometimes a bit of black magic to avoid deformation. These materials already require some experience, although their resistance is excellent. For example, nylon is the original material in which many of the sheaves and plastic parts that we find in our boats are made, and from there to infinity, because there is currently a true explosion of filament variants, reinforced with carbon fiber, Kevlar, or even graphene, to further enhance their mechanical and thermal properties. And of course, all these materials are available in a lot of different colors. For example, our Raspberry Pi case in 3 colors.
Wow, how cool.
3 colors chosen completely random. Yes.
Yes, 3 random colors.
In the post on the web, I leave you some links to the materials that I have used and that have worked well for me. But in short, if you're going to print things for the boat, PETG and TPU are probably going to be your best new friends. A lot of things can be printed. With PLM, I have printed our first ornamental test or the drill adapter for the winchi, which worked. We have also tried it with PETG printing in different orientations to give it more strength. There are even ways to embed parts, such as a screw, directly during printing to further strengthen certain areas. We've made a winchi crank in PETG, or over here, a hose adapter. And the finish is great, with the thread and everything. And we've even printed the sealing gaskets for the adapter, and it works. You can even print spare timing belts for an emergency. This is a small example of a timing belt with the exact pitch of the autopilot. There are a lot of things that already exist ready to print, but we can easily modify them and even create our own parts from scratch. Creating a part or modifying an existing one can be a breeze with tools like TinkerCAD, a very intuitive, easy to use, free and fully online design platform. It is based on predefined shapes that we can modify, combine, and convert into solid or hollow elements to add or subtract to other pieces. For example, a very simple design we can make is a spare wheel to replace a broken one. Building this, which I designed myself, is very easy. We start with a cylinder and adjust it to the size of our sheave. We set the diameter, the thickness, and we have the base for everything. Now we need to subtract a hole in the center. We insert another smaller cylinder, position it, and we can move it precisely using the keyboard cursors or by adjusting the displacement units. We can even align them automatically with the alignment tool. Once positioned, we turn the second cylinder into a hole, and when combined, central hole ready. Finally, to make the outer channel of the sheave, we use a toroid of the right size that we also subtract from the main shape.
A toroid, that is a donut.
A donut, yes, a toroid is a donut. And tada, our finished sheave. We send it to print, and if we do it, for example, with PETG, it can last us quite a while, at least until we can get an original one. But the best thing is that this way we can get a lot of things. For example, I have designed a support for my cell phone. I have modified a support for my Baofeng radio. I don't know, the possibilities are literally endless. The 3D printing thing for me, I knew it for a long time. I used it, but I don't know why I hadn't taken the leap, because right now it's so easy. I needed to have a printer at home. Let's hope for my wife's sake that it stops there, and for the moment I only have one, because I'm already thinking that maybe I need more, to make bigger things, to make more things at the same time. You can make pieces in chunks. Right now I'm making a piece that doesn't fit in the printer, but I make it in pieces and it goes with screws, that is, you can do everything. A sextant. I'm going to have to learn how to use the sextant now that I've printed one. It's a marvel, you can do a lot of things, the level of customization is amazing, and above all, there is a lot already ready. You don't need to be a genius. Using them is very easy. You can use ready-made models, you can make your own, and if not, well look, you can contact us and we will print what you need. We even design a piece that you need at a given time. You can consult us. There, they are cheap, it's easy.
And for the kids' toys, and to make toys.
And to make toys and things for children. Thank you very much for your attention, surfers. I hope you liked today's episode. If so, please give us a like, subscribe to the channel. You have the little bell to receive notifications. You have all the links both in the description of the video and in the post on our website www.thelowcostsailor.com. Thank you very much to all of you who support us, especially to our Patreons who are going to be here. Any day now, they won't fit on the screen anymore. Anyway, see you in a couple of weeks in a new spectacular, and this one is going to be spectacular because it's our 100th episode and it's going to be very, very spectacular.
By the low-cost sailor. With today's episode, you really left an impression on me. Get it? Because 3D printing? Yeah, I knew it was going to be impressive,